Hello everyone. It's a pleasure to be here with you all, with this great audience. The room is full. Today I just want to briefly talk about two topics: is the lake house, and then a term that is not known by the industry, which is the beach house. So I made that up. We'll deep dive in a second, if my brain functions well on a Monday morning. But let's see. I mean, disclaimer for today is these are my thoughts, okay? These are my perceptions of the state of the art, my experience. I'm not really saying anything that you should take it as granted for sure. Use it as food for thought, or just use it as ammo for discussion. And the thing that we should look into first is, if we were data, where could we live today, right? So let's dive into that in a second. So the first place, if I am data, that I can live is the data warehouse. So the data warehouse, if you look at the warehouse, is basically we collect data from the source system, extract a lot of data using a magnitude of tools. Then the data lands on the warehouse on something that we call the landing layer or the raw layer, doesn't matter. Then it goes to another stage. Data gets modeled in a highly relational form, tabular form, relational, snowflakes, star schemas, whatever. Goes through the chain, lands on a BI or an application data model where data really suits the needs of the application, right? Then you can use many tools. Doesn't matter, Snowflake, BigQuery, Redshift, whatever. We have that capability of just structuring data for analytics. Then besides the data warehouse, we have the data analytics or the BI platform on the side where we run our reporting and dashboards. And we also have the data science or machine learning platform that needs to connect to the warehouse to just get the data out for data science and machine learning. So if we think of the warehouse, we know that it is a SQL-oriented system. So it's only SQL or mostly SQL, and the streaming capabilities of the warehouse, they are also questionable most of the times. What it does do well is really the BI part. It does it very fast and it does it very easy. So it's very easy to manage a warehouse if you compare it with other architectures. But where it lacks, in my opinion at least, it's mostly structured. So you can navigate around tables, columns, but not really semi-structured data or unstructured data. They typically don't use open formats as well. They use very proprietary formats, which creates connectivity challenges with the data science or the machine learning platform, because you somehow always need the special compute of the warehouse to get the data out or to just interact with the data. Now, the second place where we can live as data is the data lake. And the data lake, again, same value chain, more or less, different names for the layers. So you have raw, lake, and curated instead of the other layers, but potato is the same thing. Then you use different technologies, right? So here you use most often a cloud storage like S3 or GCS or Azure Blob Storage or whatever. Then you'll use Hive, and things surround around tables. When you go through the lake layer, at least, not this one, but the lake layer, things are treated as tables. Relational formats are not that predominant, I would say, but you can also have star schemas, but it's mostly huge tables with lots of dimensions and metrics. And then you have the same two platforms as I shown before, the BI platform and the data science one. What we have in the lake is we not only have SQL, but we have a lot of programming languages, a lot of different ones. What we do not have, though, is ACID transactions. We cannot easily and safely modify a row or delete a row. It's a nightmare to do that in a data lake. If you work on data engineering, you know. And also schema management is really painful. So managing schema, enforcing, evolving it, it's really painful in the data lake. What it does do well is the data science part, because it allows you to have structured data, semi-structured, and unstructured as well. The data formats are open because you have Parquet, you have CSVs, you have JSON, whatever, you name it there. And it just integrates nicely with the rest of the data science space, because those tools know how to handle those data formats. What it doesn't do very well is BI, because getting the performance right of the data lake for BI is quite tricky. You know, if you come from the era of Hadoop, you'll know that small files, they create a lot of pains when it comes to performance. Then you need to optimize the file sizes. You need to compute all the statistics and so on. So what people usually do is they replicate the data to a very fast and concurrent system, which it's what I call here today, and this is not an industry term, okay? This is a made-up term just to tell you a story. It's something named the beach house. So if you look here, this very fast, very VIP concurrent system is what we call here the beach house. But the beach house introduces a lot of, or can introduce a lot of costs in the architecture of the lake, and also added complexity as well. Now, for us to introduce the beach house, we have several technologies to do it. One of them, getting a lot of popularity, is Apache Pinot. So if you don't know Pinot, Pinot was open sourced by LinkedIn, and all the analytics that you see on LinkedIn's website, they are supported by Pinot. So those technologies, they are offered to the end user. Tens of thousands of queries running every second at almost REST API or with REST API SLAs. So these tools are really changing the game when it comes to web-facing analytics, real-time facing analytics. And also they support very well the BI side of things internally, because if they support analytics externally, they could not support things internally as well. Then the last house I can leave if I am data is the Lakehouse. And the Lakehouse is basically same architecture as the lake, but the data formats are different. Now we have formats like, we see here, Delta Lake, we have Apache UDI as well, we have Iceberg, and those were the formats that changed the game for something that we call the Lakehouse now. Yeah, you can change the layer name again, bronze, silver, gold, but again, it's the same old story. The data formats that we have now, they allowed us to introduce ACID transactions that we didn't have before, and they allowed us to have proper schema management. What they also promise us is that for BI workloads, we can optimize our data layout much better. We can easily optimize our file size. We can ensure data skipping and scanning through data in a very efficient way. And also managing all the metadata and governing all of our data with proper access controls also become easier using those formats and those standards. So it attempts to get the BI part right as well, while also collecting the exact same benefits of the lake for data science and machine learning. So theoretically, it does everything right. Now the question is, if I am data, where would I really love to live? So we saw the warehouse, and to me at least, the warehouse, I mean, it's tidy, it's a very tidy place, but it's too rigorous and it's often closed, too closed for me, right? So I want to go there, but it's closed. So I need to open the door, it's a big door. Yeah, it's kind of not my thing. So if you look at the data lake, you can swim freely in the data lake, so you have a huge lake to swim, but you need to know how to survive in the wildness, and I'm also not that adventurous, right? Then you have the beach house. And the beach house is kind of a special system near the lake that I showed you, and it's definitely a place for special occasions. I mean, it's a really nice place, but the question you should ask yourself is, would you want to live there all the time? Does it support all the analytics for your company? And maybe yes, maybe not. But what I can tell you is that, in my opinion, the lake house is really a place where you can swim freely, but you can swim freely with a comfortable and clean home besides it. So you really can take a lot of stuff throughout the year, live your life there, theoretically happily without bothering about anything else, because you have the flexibility, you have the capacity of dealing with a lot of data in different formats. You have the ACID transactions we came to love on data warehouses and relational databases. You can easily govern your data and manage your metadata and ensure proper schema management. You have the speed, theoretically, with these new data formats with a lot of optimizations for BI. You have a rich and open ecosystem, because those data formats, they allow you to connect with pretty much everything that you have in the data science and BI ecosystem. They really do integrate well with a lot of tools. And then you have a lot of nice features. You can travel in time, which sounds crazy, but you can look at your data like if it was 2 weeks ago, for example, without doing anything. It just works out of the box. Then you have many other things. But the million-dollar question of this presentation is really, if you have just built a lakehouse or will build a lakehouse, should you sell the beach house? So if you already have the beach house near the lake, should you sell it? Or if you don't have one and just build the lakehouse or will build a lakehouse, should you consider also building and buying a beach house? So remember the beach house, that very special system near the lake or near the lake house now, supported by technologies like Apache Pinot, for example. So we aim to pursue that hypothesis, and basically we started with comparing three setups, two typical lake house setups, and one beach house setup. So we used 2.7 million rows, 72 megabyte data set. So you might start looking and thinking, this guy is joking, right? So there's no way he's gonna test these systems on this type of data sets. Well, it was tested locally on a very tiny Docker container in my machine, and that's the part you need to take with a grain of salt. You can, applying the principle of linear scalability, really scale these systems up, scale the data set up, and take very similar conclusions. But again, that's the part I want you to take home. If you're interested in the systems, test it in a more production-like scenario to your tasting. Here is just a POC, okay? It's just to replicate under the principle of linear scalability, one machine, one data set that replicates a more or less typical scenario for the given constraints. Let's take out some conclusions. And the first setup, it's really Spark plus Delta. So if you look at Apache Spark, is probably the most well-known query engine and big data framework that is on the industry. So we started with Spark plus Delta. We had, launched this aggregation query there 30 times in a loop. We got on average 600 milliseconds. Then we introduced Presto as the Lakehouse query engine to interact with our BI system to support all the dashboards and the fast SQL queries. And we cut cut it down by half, which indicates that query engines like Presto and all the stateless MPP engines, they do a good job on supporting the BI workloads, business intelligence workloads for the Lakehouse. And then we introduced Pinot as the beach house. And Pinot did it 6 times faster than Presto, okay? So same data set, same query, 6 times faster. So you might look at these results and think, damn, I should keep that beach house, right? Or I should at least try to buy one. Well, not so fast. Let's go through what we call the Lakehouse bricolage kit, right? So first thing you should know about is really model your data in the Lakehouse, okay? So using a Lakehouse doesn't mean you don't need to model your data. Think about the table structures. Think about, the kind of columns you need. Only the columns you need. Don't grow the data sets unnecessarily big. Think about the metrics. If you need to aggregate the data, aggregate the data. There's a good post there. I mean, the author is a bit sketchy, I don't know, but you can look at the post and see if it interests you. But the call out is still model your data, still cherish your data, and whenever you need to aggregate it, also aggregate it. The second part of the bricolage kit is just look at the data layout. You need to optimize the data layout so that you scan through the data fast, so that you are able to skip unnecessary data for the query processing as well. So there's many techniques. There's partitioning, which segments your big table into smaller fragments that you can filter easily. There's optimize, that compacts the small files into bigger files, and they theoretically are faster for scanning and for processing BI queries. There's clustering techniques like Z-ordering or liquid clustering now with Data Lake 3. And what they do is that they arrange the data, the similar data together, so that when you sort by or group, it makes things faster as well. And when you filter it, it also makes it very fast to skip the unnecessary data for that specific processing. You also have techniques like getting rid of old data with vacuum and so on. Those can also be relevant to you. So all of those techniques apply. They can theoretically make the queries faster and make the data set more efficient. And the third part of the Lakehouse bricolage kit is really the statistics, okay? Whenever you can use statistics, if you come from a relational background, just that computing statistics for tables can do a big difference. Because the query optimizers, they can really do a good job with the query plan and execute it more efficiently. So there's file statistics, there's table statistics that keep track on the number of records, column statistics that keep track of the minimum and maximum for a column. And what that allows is it allows the query optimizer to understand which data is being processed and how to efficiently go through it. So there's the final tip. So in this POC, I went through all that optimization, and I did collect a marginal benefit by applying it on Delta Lake, but I didn't drastically improve the results. So Pinot was still 6 times faster than Presto, and around 12 times faster than Spark. So you might think, okay, what's the main takeaway out of this presentation? It's really go through all the bricolage skills that you have to pimp your Lakehouse, right? It didn't do the job for my POC, but I was using a very small and special data set, and I was just firing a query that doesn't filter the data enough. So I didn't collect all the benefits of applying those statistics. So if for your use cases, you usually process big data sets and you don't filter them quite often, maybe you do indeed need, a special system to index heavily the data like Pinot does, and to aggregate it also on the fly, for example. But if the bricolage skills cut it for you, if it optimizes to your requirements, that's fine. Just maybe you don't need the beach house. If it doesn't cut it for you, and if you can afford the price, then for sure, keep your beach house or consider build and buy one besides your lake house. And that wraps it up for today. Thank you all. It's a pleasure to be here with you all, and open for questions. I hope you enjoyed it.
Thank you. Thank you. So we have quite a few questions, and one of the questions I was also thinking about during the presentation when you presented this benchmark. So you used mainly open source tools like Spark, Presto, and Pinot, right? What about tools like Snowflake? Like, should we consider them too when building our... Well, I know it's more like a data warehouse rather than a data lake, right? Shouldn't we forget about them because like they're quite fast?
Yeah. Yeah, for sure. So if you go into the commercial tools, for sure there's many options. I mean, to me, Snowflake is a data warehouse with data lakehouse lake capabilities. Yeah. So it's a good option. It's a good option for an abstracted data warehouse that is fast. So if that does the job for you, that's fine. I prefer more the native data lakehouse tools that allows us to have unstructured data, semi-structured, and structured, and optimize it as much as I can for BI workloads. But that's a matter of preference. Actually, the Snowflake was something I put as the beach house as well. So you can have the lake house and Snowflake as your beach house because it can be really fast for that BI specific thing. And there's many things that many people that do that. They have the lake house and then some data replicated onto Snowflake to make queries fast. And if that's a good beach house for you instead of Pinot or Druid, then go for it. It's not a problem with that.
Yeah, thank you. In the benchmark you showed us, so we saw it was Spark plus Delta, then Presto plus Delta, and then just Pinot, right?
Yeah.
So, like, does it have like this? What's the underlying storage for Pinot? Like, is it like? Does it ingest and then keeps all the data inside, or?
Yeah, so Pinot is something called a distributed data store, and the underlying storage is it's a columnar format, but it relies heavily on indices. So at the moment it ingests the data is highly indexed. So because it is highly indexed, it means that a lot of paths to go through the data, do the analytics on top of the data, it's already kind of pre-known to the system. It's not really pre-known, but it's highly optimized. And that's the secret source for the
So it
system.
doesn't have this kind of overhead of going somewhere, fetching the data,
exactly.
in some external system.
Exactly.
Okay.
And that the data sits close to the compute as well, which makes things really fast.
Okay, and so there is an interesting question which we partly talked about when we talked about Snowflake. So the question from Pablo. So I am a data engineer and I love the simplicity and robustness of SQL-based data warehouses. Given that these warehouses are simple, should we still bother with distributed systems where like we maintain them, things go wrong, or we just go with Snowflake and be happy and pay a lot of money?
No, I deeply believe that the lakehouse is the best architecture pattern we have right now. I don't know about tomorrow, but right now I do believe it's the best architecture pattern. And if you want to look into the commercial tools, you can build a kind of a virtual SQL warehouse, like with something like Databricks, for example, that is very fast on top of your lakehouse data and govern it exactly the same way as you would for a SQL warehouse in a relational world with MySQL or SQL Server or Oracle or so on. So I do believe it's the best architectural pattern to support all of the workloads in the industry for sure.